So in this follow-up video to uncertainty in measurement, I'll focus more on what the textbook tells you about it and some of the tricky pieces tricky tech questions that come along with that as well. So as you watched in the video before, you know that measurement can be described as either precise or accurate, and they had some really nice pictures. I think it was of sharpshooters, but you could also use things like dartboards to illustrate that as well. And once you understand precision and accuracy, then you can talk about how significant various measurements are in terms of significant figures or significant digits. And if you want to call them sig figs, that's fine, or sig digs, that's okay as well, because it's easier to talk about. Let's just quick review how to determine the number of sig figs or sig digs in a particular measurement. First of all, know that you want to know that if you can count something, if you can actually physically go out and count the number of cars in a parking lot, anything you can count has an unlimited number of significant digits or significant figures. Also, conversion factors have an unlimited number of significant figures or significant digits. So like in 1 centimeter, there are, let's say 10,000 nanometers. Well, this 1 and this 10,000 are unlimited number of significant digits. Don't limit yourself to just one significant digit right there. Now, there are some conversion factors that between English and metric system, that would be the number of limiting sig figs. For example, in 1 mile, there are 1,609.3 meters. Well, this is a measurement, and so it actually is limited to 1, 2, 3, 4, 5 significant figures, and you can find a lot of these changes or these conversion factors in the back cover of your textbook. But for right now, just focus on the 2 unlimited things and don't worry yourself too much about those that have metric and English systems with them as well. Continuing the review, if something has a number 1 through 9 in it, you count the 1, 2, 3, 4, 5, 6, 7, 8, or 9. Those count as significant figures. The zeros are the confusing ones. So there are 3 rules in your textbook for zeros. If zeros are in between a measurement, they count, like as in 1, 0, 0, 5, both of those zeros would count because they're sandwiched in between 2 significant figures. Zeros at the beginning of a measurement are only placeholders, and so they don't count. So like 0.02, those 2 zeros don't count. That would only be 1 significant figure. 0.0026, the 2 and the 6 would count, but the leading zeros do not count because they're only placeholders. The last one is about zeros at the end of a number. If the number contains a decimal point, then the zeros are significant. For example, 1.03, this 0 would be significant. Remember, if it has the times 10 to the something on it, ignore the times 10 to the something and only look at the number to determine the number of significant figures. This 0 would count because it is a number containing a decimal, and this 0 would count because it's a number containing a decimal. This one would have 1, 2, 3, 4, 5 significant figures in it as well. Let's look at a couple other tricky examples of the number of significant figures in various different measurements. Here's a large measurement of centimeters, and you can see that it's got a times 10 to the 12th, and the advice I give is just ignore this part. Not that it's not important. It definitely is important to tell you how large it is, but it does not help you determine the number of significant digits in a measurement. And so the significant big digits would be the 2, the 3, and then since it contains a decimal point, the 0 would count, so this would have 3 significant digits. How about this measurement? How many sig figs are in this one? Well, this one, of course, the 1 and the 3 would count, but these zeros would not count because they are previous zeros. There are ones that do not count because they're at the beginning of a number. So these don't count at all, so this would only have 2 significant digits. 70 desks. Well, since you can count the number of discs, it's not a measurement like with a ruler or with a scale. This would have an unlimited number of sig figs. Unlimited number. Remember, things you can count are unlimited number of sig figs. Here's another measurement, 5.002 times 10 to the negative third gigamoles. Now remember what I said, ignore the times 10 to the negative third part and just look at the number to determine the sig figs. The 5 and the 2 count. The zeros that are sandwiched in between, those also count, and so this would have a 4 for number of sig figs. Or you can think of it as this number has a decimal point and the zeros are trailing the decimal, so they would count as well. Lastly, when you're doing math with significant figures, if you're adding and subtracting, then you want to look for the number of sig figs after the decimal, or the least certain measurement. So if we're taking these three numbers and adding them together, notice this has 2 sig figs after the decimal, 3 sig figs after the decimal, only 1. So this would be our least certain measurement because it only has 1 significant figure after the decimal. As long as these are all the same units, of course this is centimeters, centimeters, centimeters right here, then this would be our least certain. And so after we added them up, we would have to round to 1 decimal place right here. Since this is our least certain measurement, our correct answer would be reported as 104.8, and then we'd put centimeters after that because we would only have 1 sig fig that we knew of after the decimal place. Multiplication and division. When you multiply or divide numbers together, you want to add the total number of sig figs in a measurement, and then the one with the least is the one that you want to report in your answer. So these two numbers multiplied together, you can notice that this has 4 significant digits in it, this one has 2 significant digits in it, and so our answer should be reported to the one with the least, which is only 2 significant digits. So when we do the math, go ahead and write down all the decimals to start with, but only round it to 2 sig figs, because this factor right here only had 2 significant digits in its measurement, and so we'd have to round it to 32. So look to the next number right here. If it's 5 or more, round up. This is not 5 or more, so leave it at 32. Good luck with your sig figs.